We've mentioned the term URL, but we have not really defined it yet. URL stands for Uniform Resource Locator. Every resource on the web has its own unique address in the URL format. The first part of the URL tells the server what protocol is being used. In this case, we're using HTTP. The next part of the URL is the unique name of the server. Every name maps to a unique IP address, but names are easier for humans to remember. The next part of the URL is the port number. If you leave this out, 80 is used by default, because that's the default port for web servers. The next part of the URL is the path to the resource. This typically corresponds to a directory on the web server. And the final part of the URL is the name of the content being requested. Remember, this doesn't have to be an HTML page. It can be an image, a PDF file, a media file, or anything else the server feels like serving. If you leave this out, most servers will look for an HTML file named index.html. Now let's look at an example of how everything works together. First, a user types a URL into a browser. Based on the URL, the browser creates an HTTP GET request. The GET request is sent to the server. The server finds the page identified in the URL. The server generates an HTTP response that includes the page. The HTTP response is sent to the browser, and the browser renders the HTML. In the example from the previous slide, the web server application found an HTML page that already existed on the system. Pages that already exist on the system are called static pages. Serving static pages is easy for a web browser. However, web applications are usually dynamic. They serve pages that change based on some external factors, such as user input. For example, suppose the user types a name, like Eleanor, into a form and submits the form. A dynamic website could use that information to send a new page back to the client that says, "Hello, Eleanor." A new HTML page would be created each time based on the name that the user types into the form. The diagram on this slide shows how this might work. The client sends a request to the server, and the request contains some parameters. The web server application receives the request and sends the parameters to a helper application that generates an HTML page based on those parameters, and then sends it back to the web server application. The web server application treats the HTML it receives as a static page, and it just sends it to the client in an HTTP response. A non-Java helper application is typically called a CGI program. It may be written in Perl, Python, or PHP, for example. Helper applications that are written in Java are part of a much larger framework, Java EE or Java Enterprise Edition. The framework typically adheres to a specific directory structure, and it involves servlets and Java server pages, or JSPs, and also enterprise Java beans. Using Java to build dynamic websites is not a lightweight solution, but it does give you all the power of the Java language, including static typing, multi-threading, and all the benefits of an object-oriented language, like abstraction, encapsulation, and information hiding. Finally, there is another way to build dynamic websites that's becoming more and more popular, and that is by using JavaScript. The popularity of this approach comes from the fact that browsers can already run JavaScript code that's embedded in an HTML page. So even when you're using Java or a CGI script on your server, you often will combine this with simple JavaScript code embedded in your web pages, so that the browser does not have to rely on sending a request to the server when it needs to do a simple calculation. Therefore, JavaScript is considered an effective client-side technology even when the server-side technology employs another language. However, JavaScript has recently been gaining favor as a server-side technology as well, with the introduction of sophisticated libraries like Node.js and AngularJS. We'll talk more about JavaScript in a later module.